Okay, for today's video, we'll be talking about exponential growth of functions. So we are given our equation. We have y equals 2 to the x, and we're going to have to go through and do several things. We're going to go through and determine a table of values to help us go through and create the graph of the function, which we're then going to use to interpret using these 5 characteristics of it. So I'm going to go through at this point and start our recording. Okay, the easiest way to type this equation into your calculator is you're going to do your base, which in this case is our 2. We're going to hit our to the power of our caret key right here, and then type in our exponent in parentheses. That way whatever we have isn't going to mess up. And so I want to go through now, and we're going to fill in our table and plot our points to where we can draw our graph. Alright, and now that we have our 5 points, if you look, it kind of looks like it's starting off kind of flat over here, and it's going to go through our points like this, and go upwards forever, and create our exponential graph. And this is what a graph of an exponential growth function looks like. So, now that we have this, the first thing we have to figure out is our domain. Domain is always the x values of the function. So if you look, the furthest left we have here is we're going to the left forever and ever with an arrow, so that's negative infinity. Farthest right we're going is an arrow, so that's also going to be an infinity. And infinities always get parentheses when we're doing interval notation. Remember that. For your range, we're talking about our lowest. As we're looking here, it looks like we're never going to cross this line right here, which is going to be our 0. And our highest one is up here at that arrow again, which I'm going to do in blue, which is also going to represent an infinity. So it's also going to get a parentheses. Next thing we have is our y-intercept. So if you look, there's two places you can look. You can look here on your table, or you can look here on your graph. And either place you should see it as 1. X-intercept. If you're looking here, there is our x-axis. We're looking for where it crosses there. And as we're looking, it doesn't cross it. So there is no x-intercept here. Sometimes that happens. That's okay. Next thing we have is the asymptote. This one might be a new term for you. So in case you don't know what it is, we're going to define it really quick. An asymptote, in general terms, is a line that a function is never, ever going to cross or touch. It's going to be something we're going to get really close to, but we're never going to touch it. Think of it like a brick wall you're driving along. You don't want to touch it or crash into it because then you're going to get hurt. But you're going to want to try and get as close to it as you can. Now with exponential functions, our asymptotes are always going to be horizontal. And since they're horizontal, they're always going to be done in terms of y equals. So, in this case, it crosses at 0, so that's one way to get y equals 0. Another way to look at it is what number is on the end. There, then it's going to have to be, your asymptote is going to have to be 0. No choice.